In this video, we want to explore vector addition. If I have two vectors, how can I add these two vectors together to get a third vector? Now, I should specify that. Two vectors added together will give you another vector. There are two different ways to multiply vectors. One's called vector multiplication. Well, they're both vector multiplication, but one gives you a scalar and the other gives you a vector. So it's not always going to be the case where if you multiply two vectors, you're going to get a vector. But in the case of vector addition, the result will always be a vector. And if you think about it, that must be. Because, as we've said before, if I want to add two quantities in an equation, then they must have the same units. Here, my vectors are living in the same coordinate plane, so they're going to have the same units, whatever you're in, centimeters per second, kilometers per hour, meters per second squared, whatever. And so when I add those two together, I'm still going to get those same units, and my new quantity will also have magnitude and direction. And that's what we want to find out. If I add these two vectors together, what is their overall magnitude of the resultant, and what is the direction of the resultant? Now that's what we call the sum of two vectors. We call that the resultant, okay? So the resultant R is going to equal the sum of vector A plus vector B, okay? And so we just use the capital letter R for resultant. It's the generic term we use if we're calculating the sum of two vectors, or sometimes it's also used for finding the magnitude of a vector if we have both components in the x and the y direction, okay? Now, vector addition is very, very simple. The algebraic or the mathematical way to do it is to simply take your x components, and that will be your overall component in the x direction, and then take your y components, and those will be the components in the j direction. So if my two vectors have the points in the coordinate plane, if their tips lie at the point 4-1 or 4, 1 in the case of B, what this means, this is basically algebra, okay? When you plotted things in algebra and you used points in a coordinate system, they look like this, and our components are the exact same. So what this means is that 4 units in the x direction, so Bx is going to be 4, Ax is going to be 3, by is going to be 1, and ay is going to be 5, okay? And so all I have to do to find the components of my resultant are add them up, okay? So ax is 3 plus 4, and that's going to be in the I direction, and I'm going to have 5 plus 1 in the j. Okay, or in the y direction. So my final result is going to be, well, we don't need parentheses here. So 7i plus 6j. So those are my two now components of my resultant vector. And now that I have my resultant, the two components, I can also calculate A, its magnitude, and B, its direction. But first, before we do that, I want to show you how we obtain this also graphically. Vectors live in a plane, and vectors can be moved around as long as you do not change the magnitude or the direction. So I can shift my vector B anywhere in the plane here as long as I don't change its magnitude and its direction. So we can do one thing that we call the tip-to-tail method, and that is to either displace either of my vectors and move them so that the tail, we call the point at the origin the tail, and the point with the arrow the tip, I'm going to move one of my vectors so that the tail is at the tip of the other one. And if I move my vector B, I'm going to see that as long as I don't change its magnitude or direction, that it will be here. And if I've drawn this appropriately, then this vector should have the same direction and magnitude as this vector, okay? And that's because they're the same vector. And notice that this new point is where my new overall tip is. So that means that is where my resultant is. So if I draw a resultant from my origin, it now lies at this new point. I didn't quite hit it completely, but again, to within the ability of my artwork. Now, one question you may be having is A plus B the same thing as B plus A? Well, we can answer that question over here with a resounding yes. Vector addition is commutative. It does not matter which order I add these in these parentheses. AX plus BX is going to be the same thing as BX plus AX. What that also means for the graphical method is that it does not matter which vector I move to the other's tip. Okay, it does not matter, using the tip to tail method, it does not matter which vector I use. I can also displace vector A, and if I displace vector A to the tip of vector B, right, I'm still going to end up at this same spot. So either way, this is my new vector A. Actually, it's not really a new vector, it's the same vector, and again, this is also vector B. It does not matter where we end up. And so, either way, I'm going to obtain the components 7 in the I direction and 6 in the J direction, or 7 in the X and 6 in the Y. And now that I have this, I can calculate my resultant and my angle. So, what is my resultant going to be? The magnitude of my resultant. If I want to calculate the magnitude of my resultant, this is going to be 7I plus 6J. So again, the magnitude is going to be found from the Pythagorean theorem. This is going to be 7 squared plus 6 squared. This is going to be the square root of 49 plus 36. And that is going to be the square root of, 85? Which is going to be a little over 9.2 or so, okay? And so that is how I can get my new resultant. So my new resultant is going to be around 9 plus units, okay? A little bit more than 9. And the new angle that it's going to make, the angle theta, is going to be found from the inverse tangent again, okay? So my angle that it makes with the x-axis is going to be found from the inverse tangent of 6 over 7. And that's going to be a little less than 45 degrees. Okay, that's going to be a little less than 45 degrees. This means that your y-coordinate is slightly smaller than your x-coordinate. At 45, they're equal. At above 45, your y-component is just a little bit larger than your x-component. So this is going to be a little less than 45 degrees, maybe roughly 40 degrees or so, all right? But that is how you do vector addition. What about vector subtraction? Okay, what if I now want to perform vector subtraction? Okay, so now I want to take my vector A, and I now want to subtract vector B. Okay, what is my new resultant going to be in this case? So if I want to take my vector A and subtract my vector B, I do what I did before, AX and BX in the I direction, plus AY, BY in the J direction, but now instead of putting plus signs here, I just put subtraction signs. This is just going to be a subtraction sign, okay? So now, all I have to do is take my AX component, which is 3, and subtract my BX component, which is 4, and that's going to be my magnitude in the X direction. And 5 and 1, so I'm going to take 5 minus 1, and this is going to give me my magnitude in the Y direction. So this is going to be -1 in the X direction, and this is going to be 4 in the j direction. So my new vector is going to be, I need to go into quadrant 2 here. I'm going to be -1 unit in the x direction. I'm going to be 4 units up. And graphically, what this is the same as is flipping vector b across the y-axis. So if I flip vector b across the y-axis and I get a vector of the same length but with the same angle with respect to the x-axis here, and then I displace that vector, okay? I displace that vector. So now if I take this vector and I take it up to vector A, right? If I take it up to vector A, I now get that new resultant, okay? Oops, that's not the resultant, that's the vector B. Vector B lies here. This is -b. And my new resultant vector is here. And that is a little bit in the negative x direction, as we said before, and then positive in the y direction, which is what we have. So my resultant of taking A minus B is going to be this new vector here. You can also look and see that if I displace my new resultant and move it over here, it's exactly the same length as the distance between my two tips. Okay? This is also my new resultant R. So it is the distance between my two tips pointing in the direction of the tip of your first vector here. Okay, so graphically, that's another way to do vector subtraction. But other than that, all you're really doing is changing your plus signs here into minus signs, but the algebra is again exactly the same. If I wanted to calculate the magnitude, I would take -1 squared plus 4 squared, and I would get 17. So the square root of 17, 4.1 approximately, and then I would take the arctangent of 4 over -1, and that would give me this angle right here, and that would be the direction of that magnitude. So again, nothing too mysterious, and that is how you can subtract two vectors. We'll take care, and we'll do projectile motion in the next video.